Hello friends, this is our third video of operating system. Here we see types of scheduler. Scheduler type of programs which is used to select the process, means which process will go to next state. The first is long-term scheduler. Long-term scheduler has the work. Long-term scheduler's job is to select the which process will go from new state to ready state. This another is short-term scheduler. Short-term scheduler, uh, short-term scheduler, short-term scheduler is used to select the processor which are in ready state, means in RAM. So the short-term scheduler decide which process will go next on CPU. The loading of process in CPU done by dispatcher. Then the third one is midterm scheduler. Midterm scheduler schedule which process go to secondary memory when the main memory is full. We see in RAMs when the RAM is full, then the process which are not opened since long time, then this type of process will go in secondary memory for some time to free up the space in main memory. Here the state diagram of the schedulers, and here are the features of schedulers. The midterm scheduler increase or decrease the degree of multiprogramming by swiping or removing the process from the main memory. Here the short-term scheduler does not affect the degree of programming, and the long-term scheduler can only increase degree of programming. Here the short-term scheduling, also known as CPU scheduling. The CPU scheduling makes selection of process to run next in CPU. Here the goal of this is to minimize the wait and the turnaround time, maximize CPU utilization and throughput. Here the terms used in scheduling times. The first one is arrival time, the time at which the process is admitted, means time at which the process comes from secondary memory to ready state. The burst time or service time, the amount of time the process run on CPU, means how much times the process run in CPU. Completion time, the time at which the process complete execution, means the time at which the process has been complete its execution. The turnaround time, the time of time a process is spent from arrival to completion. Here the formula is also that turnaround time is equal to completion time minus arrival time. The waiting time, total time is spent by the process in ready queue for waiting CPU. The waiting time, the total time is spent by the process, means that when the process come in main memory, then the process will wait for its chance to get into CPU. So the time, so the waiting time is considered as waiting time. Response time, the time taken to get first response of the process after arrival. When the process arrive in main memory, then from waiting time, the first waiting time period in which the process go to the CPU for execution, and the throughput, the number of process executed per unit time. Here the scheduling algorithm, the first one is first come first serve. Scheduling characterizes the smallest arrival time process first. When the two processes come together, then there is a tiebreaker. So we will decide the process by their process ID, the smallest process ID. The process having a small process ID will get more priority. Here the example. Here the three processes and their arrival time and the burst time complete. Here the P1 and P2 and P3 comes at the same time, same arrival time, and the burst time of P1, P2 and P3 is given that. Here we create a Gantt chart starting from 0 always. Here a Gantt chart which will start from 0, and we have the first, there is a same arrival time, so we consider process ID for their priority. Here the first smallest process ID is P1, so P1 get most priority. Here first from 0 to 24, there are 24 burst time, so the 0 to 24 was P1 process get into the PC, the CPU, and the second P2 will go for execution, and then P3. Here the completion time, the first in 24, first 24 times P1 process will complete the execution, and then 24 to 27, there are 3 unit burst time P2, and from 27 to 30 there is a process 3 with the burst time 3 unit will complete the execution. Then the turnaround time, this is the total time the process is spent in main memory. Have the 24 0 to 24 P1 process will completed and go and taken out from main memory, and then the process P2 will complete in 24 unit times. So at 27 unit time, process P2 taken out from main memory, and then process 3 will completed in 30 unit time. So at 30 unit, the process P3 taken out from main memory. Here the similar type of question, number second. Convoy effect. Convoy effect comes when the problems comes when the long process come in the CPU, so the other process not get a response for the long time. As we know, first come first serve, when there is a long process comes in main memory and get into the CPU for execution, so it will take a long time to process. So other less burst time process are still waiting CPU waiting for CPU and long time. Convoy effect. The problems of convoy effect come in convoy effect problems arise when long burst time process acquire the CPU and the other process is still waiting to acquire the CPU. Then the advantage of FCFS. Here the advantage of first come first serve scheduling. Advantage: easy to implement due to its simplicity. It is easy to implement. No complex logics required. No starvation if the process if the process have definite time. And the disadvantage: no option of redemption. Here the FCFS is a non-preemptive type scheduling algo. Due to non-preemptive nature of this algo, there is not possible to forcefully taken out of process from CPU, due to which the convoy effect make system slow. The next scheduling algo is sort job first, means the process having shortest burst time. If the two or more processes having same burst time, then the priority is taken by the help of FCFS and then process ID. This is a non-preemptive type algorithm. Here the example, in which there are three processes P1, P2, P3, and their arrival time, burst time. Arrival time is same and the burst time is different. Okay, so solve the problem with the help of Gantt chart. Here, the Gantt chart is starting from 0 unit time, and so in SJF the process having low burst time get more priority. So here there is a two processes having same burst time, so we get priority on the base of arrival time, but there is arrival time also same, so we get it from their process ID. Process the having less process ID get more priority. So the process P2 get first priority, so there is have 3 unit burst time, so 0 to 3 P2 process acquire the CPU, and from unit 3 to 6 process 3 acquire the CPU. After these two processes, the process P1 comes in CPU, and it will take 24 unit burst time. After 30 unit times, all process has been complete. Here are the completion time of process 1, 2, 3 is as we saw in Gantt chart. Turnaround times, total times taken by the process from its arrival to completion, and their wait time. Here the advantage, the minimum average waiting time and the average turnaround time is minimum. The SGF advantage of SGF is having minimum average waiting time from all non-preemptive scheduling algo. Better throughput in continuous execution. Here there is a continuous execution. Disadvantage, no practical implementation because the burst time is unknown. In starting, we don't know, we don't calculate the burst time, so it is not practically implementable. No option of redemption, as we know, we can't take the process out from CPU forcefully because it is a primitive type. Long process may suffer from starvation. If the longer process comes first, then there is a starvation problems occur.